Alrighty, so in this video, we're going to learn how to graph quadratic inequalities. So we're just going to go over a couple of the notes here really quick, just to make sure we remember some of the pieces here. So we have a parabola, which is a quadratic. That's what the shape is that it makes as a parabola, which remember, it's either going to look like this with the arrows. So it's going to open up or it's going to open down. And we've gone over some of the pieces of that. So the parabola in the form y equals a times the difference of x minus h squared plus k has the vertex h and k. So we actually call this vertex form because it's very easy for me to grab the vertex from it. Okay, so that's why we call this vertex form, and we kind of want to put our parabolas into vertex form if they're not already in them because it makes them very easy to graph. And then this A also tells us very quickly, is it opening up or down? So if it's a positive, it's going to open up like this. If it's a negative, it's going to open down, right? And then they all do something to the graph as well, because the normal, the regular graph would just be y equals x squared like this. This is a parent graph, and it would look not like this necessarily, but it has a very specific shape to it as far as, it's very uniform. And then once you start changing, that's kind of a bad way to describe it. They're all uniform, but it's the parent, meaning it's the basic one. And then once you start adding and subtracting inside of the parentheses with the x squared, you're moving it. I believe this is the horizontal movement. I hope I'm not saying that wrong, but this one is going to move it right or left, and then adding or subtracting outside of the square, outside of the x squared, that's going to move your graph up or down. And then this A term actually either widens or kind of narrows the graph. So all of these pieces do something to your graph once you start having this kind of more complicated quadratic. But the nice thing here is that I can very easily grab H and K and move on as far as, which points do I need to graph. Remember when you're grabbing this, it is x minus H. So if you're given an equation and it says x plus a number, whatever that number is, that means there was a double negative there. So you need to make sure that you put the negative in that piece. So just pay attention to that. It is minus in the original equation. So the first thing we're going to do when we're given the equation is to rewrite the given equation in vertex form, which is this form right here. And we do that using completing the square, which we've practiced quite a few times at this point. If you're a little unfamiliar with it, or if you're not super happy with the video, because I'll go a little bit faster in this video, seeing as we've already done it a bunch of times, you can always go back and rewatch those completing the square videos just to kind of have a refresher on it. So second, after we've completed the square and we've put it in a vertex form, we're going to find 4 points, 2 on either side of the vertex, to graph our parabola. Remember, Alex always requires 5 points to graph a parabola, the vertex, and then 2 points on either side. It just needs that. So third, to shade for the inequality, we look at the graph. Because remember, now we're not just graphing the parabola like this. It's going to be, instead of equal, it's either going to be greater than, less than or greater than, said that backwards. So we're going to have some kind of inequality there. So if y is greater, forgot the E, greater than, we shade above the parabola. And that just means, like, if I had y is greater than, I would literally shade this area. Or this area, like this, if it was going down. So that's what I mean by above. If y is less than, then we shade below the parabola. Okay, and that means if it's opening up, we shade like this, below. Or if it's opening down, we shade inside because that's actually down, it's below. So those are just our quick reminders on how to set up the inequality and actually graph it. All right, so here we can actually see our quadratic, and we can see that we have an inequality. So what we're going to do, just like I was saying for the steps, first step is we're going to put it into vertex form. So for vertex form, what we want to do is kind of isolate these x's, and I always like to do this little plus here and put it in parentheses and then move this piece, this 11, kind of out, away from these. So this is going to be, when we had H and K, this is going to be my K. Although that's not quite done yet, so don't put that in as your vertex yet. We still have to finish this. So the other thing we want to do is we want to remove any like terms. So I can divide both of these by 2. It's going to make it not only easier, but it's necessary for completing the square because 2 is not a square. If by chance this was a square, then we could just keep moving, but it's not, so we need to remove it. So I'm going to divide everything by 2, like this. So I'm going to have x squared minus 4x plus something. That something is what's going to help us complete the square here. Oh, and I forgot. We're going to actually add it to that too. Oh, no, I'm fibbing. We're going to subtract it from that outside of there. Because basically, we're adding something here and we're subtracting here, so we're really not changing anything. We're just kind of moving things around to make it kind of seem as though we've changed a lot, but really we're just scooching some of the piece inside of the parenthesis. So I know that kind of sounds funny, but that's the way that it works. You can also move this to the other side of the inequality, and you could have, this section here would be y plus 11, or minus 11 actually, is greater than or equal to this section. But we kind of want it to be on the same side so that it's in the full vertex form. Okay, so now what we do is we take this middle term, we divide it in half, and then we square that, and that gives us 4. So by chance we come back to 4, and that's what we're going to add inside of here is 4. And that square is completed, but in order to know what to subtract out here, we do have to take into account the fact that we took that 2 out. So that means we would have divided down the third term as well. So it's not just 4 that I want to write out here. It's 4 times 2, which is 8. So just be very careful about that. If you divide a factor out before you add or subtract, in this case, because we're on the same side, subtract it from the outside, I need to make sure I take into account what I factored. So now I have 2, and then we can actually write this in factored form, because since it's a square, I can just go square root of the first term, square root of the last term, and then it's going to be minus squared, like this. Because this is the only way. Negative 2 times negative 2 will get me positive 4. Negative 2 plus negative 2 gets me negative 4. So just, that's one of our videos that we've done in the past. And again, if you need a little reminder on that one, you can always go back and watch those different types of videos. So this one is perfect square trinomials, I believe is what that video is called, if I remember correctly. So now I'm going to go 11 minus 8. So it's 8, 9, 10, 11. That would give me 3. All right, so this is in vertex form. So now I know what my vertex is. It's going to be 2 and 3. So I can focus my points around 2 and 3. So I'm going to go 1, 2, 1, 2, 3. So this is where my point would be, is right here. And then I can just keep moving from there to find the rest of the points, right? We want to center them basically around that vertex. That's very, very helpful when we go through and we're looking at those pieces as far as centering them. Really quick, I wanted to make sure, I was going to pull up my other table here. All right. Sorry, little pause there. All right. So we have our XY table, and sometimes we do kind of a bigger XY table so I can actually have my kind of work in there. But here's my vertex. It's 2, 3, like this, because that's H and K, right? So that's my vertex. And then I'm going to go 1, 0. So those are 2 points that are going to be to the left. And then I can go 3, 4. Those are 2 points that are going to be to the right. And you want to try to keep them as close as you can, because if you go even a step out, sometimes Alex kind of gets a little bit confused and it'll start graphing a little funny. So try to just keep them very, very close. Don't go any farther away than just like counting by ones, basically. All right, so then we're going to go through and we're going to plug this in, and you can plug it in to, honestly, either one you would like to plug it into. It's not really a big deal if you plug it in to the vertex form or back up here. I kind of think back up here might be a little bit easier. So if I start with my 0 here, I'd have 2 times 0 squared minus 8 times 0 plus 11. Well, all this cancels out because anything times 0 is 0, so I'm left with just 11. And then I can go down to 1. So 2 times 1 squared minus 8 times 1 plus 11. I get 1 squared is 1 times 2 is 2 minus 8 times 1 is 8 plus 11. So now I have 8, 9, 10. Oh, sorry, that's minus. Silly me. Negative 6. Make sure you're paying attention to your negatives there. So 2 minus 8 is negative 6 plus 11. That's going to be 5, positive. Now, one thing we should notice, and this is something I've brought up in a lot of other videos, is we should see a mirror happening. So I already know that this one should be 5 because this one was 5, and the next one should be 11. We do want to confirm that just to make sure we're doing the math correct here, okay? Because otherwise, you know, that can mess us up a little bit. But this mirror should be happening. If it's not happening, then we're not going to have that nice parabola shape. Something's a little off, or maybe we didn't find the vertex correct. So just make sure you're paying attention to that. So we're going to go through, and I'm going to go 2 times 3 squared plus, minus 8 times 3 plus 11. So 3 squared is 9 times 2 is 18. Okay, and then I get minus 24 plus 11. So 18 minus 24, let's see, that's 2. And then 4 more, that's negative 6 again. Plus 11 is 5. So yay, we did end up with 5. And then we're going to look at that last one. So 2 times 4 squared minus 8 times 4 plus 11. So 4 squared is 16. 16 times 2 is 32. Minus 8 times 4, which is also 32. Plus 11, so 32 minus 32 just cancels because anything minus itself is 0. So look at that, we ended up with 11 again. So again, ahead of time, I should already know, once I found the first two, either on the left or the right, I could have done either one first, it should be mirroring like that because that's going to create my nice little arch. So now I'm going to go 1 and 5, 1, 2, 3, 4, 5, and then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'm going to go up just a little bit here, kind of the next square would be. So then I'm going to go over to 3 and 5, and you notice they're right across from each other. That's what we want. And then 4 and 11, they should also be right across from each other here. And then you're going to go like this. And there's a little button to click to snap this. So the little button, I think it looks like this, and it's going to have some kind of graph on it. It's the graphing button, literally. It's going to snap that for you. You do not have to draw that. Okay, and our last step here, because this is the parabola graph, we have to do the inequality. So it's greater than, so I'm going to shade above. Basically above that vertex. Think of it that way. We're shading above the vertex. Okay, so right here, and I know this is all above the vertex too, but when I say above the vertex, I mean like right above it. Or right below it when I say below. Okay, so be careful about that idea. Don't get too wrapped up in, well, all of this is above too. I mean, it's either inside or it's outside. So if it's opening up and I say it's greater than, it's inside. If it was less than, it would be outside of the parabola. And it's all of the outside of the parabola. And then same thing if it was opening down and it said greater than, it would be all of the outside. If it was opening down and it said less than, then it would be all of the inside. So just, pay attention to that. But really what I'm saying is vertex. It's either above that or below that. And then that tells you the area to shade. Okay? Alrighty, so that is how we do this, guys. So again, I know it's a little bit of work just to get to the parabola part, but we've practiced this quite a bit at this point, so we should be pretty good at graphing parabolas. The new part here is just the shading. Alright, so go ahead and get on Alex and give it a try.